there's situations where you're given the f function and then you have to graph the f prime function. This right here is going to be our f function. So I like to write that this is f of x, the y-axis. It kind of helps label the graph. And so I'm going to graph the f prime function. So we're going to do that over here on the side. Now the y values don't matter, the x values do. Okay, so we have x right there and we have f prime. Remember, y values matter, or x values matter, the y values don't. This is x. These x's over here match up with these x's over here. Okay, so here's some of the facts, or some of the things that I think about when going from an f function to an f prime function, or an f graph to an f prime graph. For f's, your extrema, and the extrema are the maxes and mins. The extrema gives you the x-intercepts for the f primes. So actually, I should have wrote an x right there. So this gives you the x-intercepts. The extrema give you the x-intercepts. The steepness of the line for f. I'm sorry. The steepness of the line gives you the distance, the distance that the point is from the x-axis for the f prime graph. And then this one right here, this bottom one, is kind of related to this top one right here. If you have a negative or positive slope, that's related to the line being above or below the x-axis over here. Okay, now if I just give that to you straight, honestly, the only one that makes sense is probably this one right here. And these ones are kind of like, what are you talking about? So let's get started with this one. So we're going to look at x equals negative 5. Now x equals negative 5 is right here. So let's go over to negative 5 on our other graph. 1, 2, 3, 4, 5. So we have negative 5 right there. So I'm trying to figure out where the point goes for negative 5. So I'm looking over here at negative 5, and what you have to think about, it's so weird. You're totally thinking different than what you would normally think about in order to graph. At this point, if I drew a tangent line, oh, my tangent lines are horrible. Okay, that's a close tangent line. Is that tangent line positive or negative? Positive. Yeah, it has a positive slope. So that means over here at negative 5, my point's going to be somewhere up here. Doesn't really matter where you put it, but you just have to make sure that it compares well with the other points. What do I mean when I say that? I mean this. Let's look at x equals negative 1. So if I drew a tangent line right there, is this slope going to be steeper or more shallow than the other slope?
Shallow. Yeah,
that one's going to be more shallow. This doesn't slope as much. It's not really steep right there. And remember, steepness determines the distance it is from the x-axis, which kind of makes sense. Like if I were to assign this a slope number, let's pretend that this slope is 3. What would this one be? What would the slope be for that one? I mean, just a guesstimate.
Less than 2?
It looks like 1/2 almost. I don't know, because you just go up 1 and over 2. That's what it looks like. So this slope right here is closer to the x-axis over here than this slope right here. That would be farther away from the x-axis. So I know that's not 3. The slope is not 3. I just threw out a number right there. So let's just put a point like up right here. And then for negative 1, we have to put a point that's closer to the x-axis. Right? Because remember, f prime means slope. So whatever you're graphing here, you're caring about the slope at that point. So let's look at another number. Let's look at x equals 1. Is the slope positive or negative right there? It is negative right there. Let's see. Let's use a different color right here. This is a negative slope for a tangent line. It goes down. And then if I looked at x equals 5, and I were to plot a point right there and do a tangent line, is that tangent line, does it have a steeper slope, or is it more shallow? It's steeper? Okay, so that means the slope of this one at x equals 5 is going to be farther away from the x-axis. The slope of this one at x equals 1 is going to be closer to the x-axis. So let's see what that looks like over here on our graph. This would be 1. See, 2, 3, 4, 5. That would be 5. This one, for x equals 5, we need to have a slope that's farther away from the x-axis. And this, for x equals 1, we need to have a slope that's closer to the x-axis. Now, because we're estimating this, you kind of have to trust that you're supposed to have a straight line for this. And that makes sense. because this is a parabola. That means it's a quadratic. And if you take the derivative of any quadratic, what's the highest degree going to be?
1 less than.
Yeah, it's going to be 1 less than. Now, I know this function, and you don't have to do this. This is just kind of extra stuff. I know this function right here is f of x equals x squared plus 4. If you take the derivative of this, what is that? What is the derivative of this? Oh wait, it should be negative. You're right. Thank you. So it would be negative 2x, and then the constant goes away when you take the derivative of that. This right here is a line, right? This line right here could be that line, right? It doesn't have to be exact. This is a rough sketch. So here's the graph of my f prime function. Now there's one more thing I didn't mention, and that's the x-intercepts. This is an important one because you see this extrema right here? That is at x equals 0. What happens right here? What happens to my slope? If I'm going, like, my slope is what right here?
Positive.
It's positive, and what's my slope now?
Negative.
It's now negative. Okay, so the slope goes from positive to negative, right? It goes from positive slope to a negative slope. So what does that mean? Like, why is x special? Why is x equals 0 special right here? What's the slope of that tangent line?
0.
Yeah, the slope right here of that tangent line is going to be 0. So we should have an x-intercept at x equals 0. Okay? Like I said before, the extrema matches up with the x-intercepts of the f prime function.